Okay, so we're going to do this lecture for this week online, as we talked about. This is going to go kind of fast. That's okay. It's a video. You can pause it at any time. You can also, I'm going to put this into a discussion forum, so if you have any questions, you can shoot me an email. Or excuse me, you can post to the discussion forum, and I'll be subscribed, and I'll see that you have a question, and I can answer it. All right, so we're looking at section 6.1. We're going to look at file reading basics here. We want to understand the nature of data, why it's so important, and how we read data. Now, the beauty of Java is we already have all the tools we need to read everything that we need access to. We just need to know how to apply it, in this case, to files, but it's the exact same principle if you apply it to databases or online services through like a REST API or anything. It's all the same. So we're going to be looking at the nature of data, we're going to be looking at files and file objects, and we're going to be looking at reading a file in with a scanner. So what are some examples of data that we'll find online? Mostly databases, right? And you have to understand there are huge amounts of data that are being collected now. If you have one of those little, devices you wear on your wrist that tells you where, how far you walked today, your heart rate, how many hours you slept, all that data is going somewhere, right? Everything you buy online or in a store, that purchase information is tracked. And we have this huge amount of data that's out there now, and we're just starting to figure out what to do with it. And this is what I talked about earlier, and one of the reasons I was giving extra credit to attend those open data forums is this is, one of the big, new frontiers in our world is this whole idea of data science, the idea of how do we take a look at all this data that we're collecting and use it for companies to get you to buy stuff and for governments to get people to make better choices and that type of thing. So this is huge. Before we start talking about files, I want you to understand what a hard drive is. Take a look at that video. I'm going to link to that video underneath this video. So you might want to pause this and go watch that video. The engineer guide does a great teardown of what physically is in a hard drive, because that's where we're going to be getting our data from today. And once you understand physically what a hard drive is, so I'm going to pause. You go watch that. Okay. Now I want you to look at where the data is stored on a hard drive. So you see we have sectors, tracks, and platters. When that hard drive is spinning and the head is in one position, one rotation around, that's a track, right? So that track of data, it's just magnetic ones and zeros, but it needs to be broken up into pieces. Each of those pieces is called a sector. Traditionally, a sector is 512 bytes. We're just going to say that. A sector is 512 bytes. And then each platter has a series of tracks and sectors on it. I remember when I was a wee lad buying a hard drive online, which was a new thing back then. And when I got the hard drive, it didn't say how big it was. I had to multiply the size of a sector times the number of sectors times the number of tracks times the number of heads to actually figure out the size of my hard drive to see if they had ripped me off. Yeah, that is where data is actually stored. So when you're typing out something in Microsoft Word and you hit save, that data is written to one of those sectors somewhere on the hard drive. A file is a collection of information that's stored on a computer and assigned to a particular name, right? It also has other attributes like the time it was created, the time it was last modified, the owner, the permissions for the group, and that type of thing. We don't need to get into that in this class. Traditionally, in most operating systems, we indicate the end of the file, we indicate the type of the file by the extension, right? TXT is a text, JAVA is a Java file. But if you actually look at the data that's in a text file or in a Java file, it's exactly the same, right? So be aware that extension isn't always the most useful way to figure out what type of a file is. And when you're a professional writing code, you're actually going to ignore that and look at the header of the file. Most file types have a header that describes this is what's going in here. This is a JPEG, this is a Word document, that type of thing. So how do we create a file in Java? Or how do we access a file, right? Well, we create a new file with the name, with the object type file. and then we create a new scanner based on that file. Remember before, when we created a new scanner, the argument we sent to it was system.in. Now we're going to send in that file handle. Let's do that. Let's go to BlueJ. I've created a new class, or a new project called Hamlet. So let's create a new class, and we're going to call this Hamlet 1. And like always, I got to get rid of all this crap, and I have to get rid of all of that, and I need to make a public static void. And if I compile that, it compiles just fine. Now, because it's empty. Now, before I actually open that file, which I'm going to read from, the file has to exist. Where does it have to exist? Well, if we go back to our PowerPoint, notice this name.txt up here, right? If I just give it the name, that's what we call a relative path. So that's relative to where the Java file is running. In this case, it must be in the exact same file, a folder, as the executable. So for me, on this system, you see here, I have Hamlet under my BlueJ app, in my BlueJ 3.1.5 folder. In there I have Hamlet. And in here, I can create a new file. Let me do it using Vim. And I'm just going to put in here, this is data, more here. And then I'm going to do file, save as. I'm going to, wait a minute. And I'm going to, where is, now I gotta find it, but it is somewhere. Okay. And now you see that name.txt is within that folder. So now it should open it up, right? If in my BlueJ code, I put file f equals new file name.txt. And then I put scanner s equals new scanner based on that file. So this scanner can only read from that file. So now I should be able to read. And if I click compile, now it grumbles at me, says I cannot find the symbol file. This is another issue with importing. So the solution is import java.io.star, because we're actually going to need a few different things from java.io. Now when I compile it, now I can't find scanner, because that is import.java.util.scanner. All right, so now it can find file, now it can find scanner, but it's still grumbling at me, right? It is still grumbling at me. Let's go back to our PowerPoint here and go along a little bit. This code won't compile because of what's called a checked exception. A checked exception is an exception that must be handled. You are not allowed to ignore it. You either have to catch it or you have to throw it. If you throw it, you handle it by saying, I don't handle this, whatever. Let the next guy handle it. Or if you catch it, that means that you create some type of error handling. It says, you know what, if we can't find this file, we will do X, Y, Z. And if we go back to BlueJ, we see, unreported exception, file not found exception, must be caught or declared to be thrown. As part of my header for my main method, I need to add the throws clause. Throws file not found exception. And let's see if that, okay. And when I do that, then the class compiles just fine. All right, so those are the things that you need to be aware of when doing file I/O with Java. One, where is the file? It has to be in the same directory as where the Java program is going to be run. And two, are you throwing that file not found exception or catching it and handling it yourself? Okay, so now we want to process that data. How do we process that data? Well, let's go back to our PowerPoint. And you see we have all of these really useful methods that we can use on the file object. One, let's check. We can check to see if we can read it. We can check to see if it exists. We can get an absolute path, get the name, figure out if it's a file, find out the length of the file. And then we have all of our useful tools with the scanner as well. So I'm going to check to make sure it exists first before I actually put that in the scanner. I'm going to say if f.exists, then I'm going to create this new, actually what I should do is declare the scanner outside of it, and then inside of it, else I'm going to print out some type of message. System.out.println. File not found. And return 0. By the way, I know that this is bad coding style and I would never let you do this, but I'm trying to fit everything into a small screen here. Okay, so now if we get to this line in the code, we know that the file exists and we have a scanner that can read that file. So just like before, so let's do I don't know why I capitalized that, while s.hasNext, right? If you remember, hasNext will return true if there's anything else. So while something's next, let's say string temp equals s.next, system.out.println temp, and that's it. That's going to be our simple processing. And if I compile that, oh, my main method is void, so I can't return an int. All right, class compiled, no errors. If I go back here and I run main, I pass nothing in. There we go, click OK. And there we go. This is data more here. So, which is, if I go back to my original line, that's exactly what I have in my text file, right? Prints it out line by line, exactly what we would expect to happen. Okay, that's it. That's the basics of file manipulation, right? You create a file using the new file, you create an object of type file. You give it the name, which is either going to be a relative path or it can be a full path. As a matter of fact, let's go back to our code and just look at, oh wait, let me close that. Let me go to our code and let's say, let's print something else out here. Let's do system.out.println. The path is f dot, I gotta check it, f dot get absolute path. Oh, close that and compile it. And now when I run it, click OK, it gives me, the path is users gwhalen downloads BlueJ3. So this is the full path. Oh, I can't shrink it. You get the idea though. This is the full path to that file. You could also give that full path if the file was somewhere else. Now, keep in mind, if you're on a Windows machine, that full path is going to start with C:, or if it's on like a USB drive, D:, or whatever. But the path is the full trip through all the different folders down to that file. So if you only give the name, it's a relative path. The file must be in the same directory as the Java code. If you give the full path, which starts with C:, then it can be anywhere. But that gets pretty complicated pretty quick, so we are going to avoid that. So open the file, create a new scanner that reads the file, read as long as something is next, keep reading, and don't forget you need to import java.io and you need to throw the file not found exception. So here's what I want you to do. I want you to, okay, let's take a look at this code here, right? This code right here will count the number of words in Hamlet. Let me go ahead and throw that in. All right, in order to do this, you need to get the text of the Hamlet play. So if you just search for Hamlet, let's do .txt. Here we'll find a website. There are plenty of websites that have the actual text files for Hamlet. Let's right click and save as. And again, you need to put it into the same folder as your Hamlet class. And if I go in there, we see hamlet.txt. And if I double click that, I can see here's all the text of Hamlet. All right, so once I have that, let me throw up a breakpoint here and run it. There we go. Run the main. Okay, now I'm realizing I don't really have enough room to show you everything at once. But we're at the scanner line. We take a step. Oh, and it throws an error because I misspelled Hamlet. Let me close the output and compile it again. Terminate that. Compile it again. Let's try this again. Main. Okay, and it tells me the total words from that document are 31956. Now, if you download a slightly different Hamlet text document, it might be a little bit different. Let's step through it, which was my intention, but I forgot to set a breakpoint. So let's set a breakpoint there and run it. Click OK. And boom, we are stopped at this line here. Scanner input equals new scanner, new file, hamlet.txt. We actually combined what in our other program was multiple lines into one line here. So we're creating the new file and the scanner on one line. We're also not checking to make sure it exists. We assume it exists, and that's why I ran into the error before. All right, let me take a step, and our count starts at 0. As long as that input scanner has something next, we're going to grab the next word, and if I bring the debugger over here, you can see currently the word is 1604. That's the first word in the file, and count gets incremented. Count is now 1. Now the next word is the, which if I go back and open up hamlet.txt, we see that the first word was 1604, the next word is the, and it's going to continue on like that for the rest of the time. I'm just going to hit continue, let it finish, and it finds the same number of words, which is what we would expect. Okay, so that is what this program does. What I want you to do now is take that code. It's on page 390 in your book. I want you to download your copy of hamlet.txt, and I want you to change that code. So instead of counting every single word, it only counts words, the word and. How many times does and appear in Hamlet? And I want you to submit that code for your in-class assignment this week in Hamlet 1. Okay? All right, so that's everything from 6.1. The next video is going to cover 6.2, 6.3, and 6.4.